Hey, sixth grade. So I filmed this last night and I tried to post it and it wouldn't let me. And then I tried to post it this morning and it still would not let me. So hopefully it works this time. I'm refilming it today for you all. So this was your Module 5, Lesson 12 work that I'm going to be going over right now. You did this on Wednesday, April 1st, depending on when you're watching this. So this was Wednesday's work that I am filming for you. I'm posting it late to Google Classroom because, like I said, YouTube did not want to work for me last night or this morning, but it is working now, so that's a good thing. So again, we are doing Module 5, Lesson 12, and you had to do problems on page 151 and 152. And for this lesson, you were doing, you were moving from unit cubes to formulas for volume. So let's just get right into it. So I'm starting on page 151, and I'm going to go in ahead and start with example 1, and we are going to do A through E right now. So this is what it looks like. This is what your page should look like. And let's just get started right into it. So as you can see right here, I have 3 different shapes. I have 1, 2, 3. I went ahead and I labeled them 1, 2, and 3. This is going to help you organize throughout this part right here and just kind of organize your thoughts a little bit better. So for A, it says write a numerical expression for the volume of each of the rectangular prisms. So we know that when we find volume, it's length times width times height. But it's just asking for an expression. You don't need to write out an equation or anything. So it's just asking you just to write out the numbers that represent the length, the width, and the height. So for the first one right here, I have my length, which is 15, my width, which is 1 1/2, and then my height, which is 3. And I got those numbers from right here. Here's my length, here's my width, and there's my height. So there's that. For my second box, I have 15, 1 1/2, and 6. And then for my third box, I have a length of 15, a width of 1 1/2, and a height of 9. So that's what your little numerical expression should look like for part A. Now, if we were to move on to part B, it says, what do all of these expressions have in common? So when we're looking for things that they have in common, I want to see what's the same with these 3 shapes and what's the same with these numbers and expressions. So when I look at this, I see that all 3 of these expressions have a 15 and a 1 1/2. They all have different heights. So the height for this one is 3, this one is 6, this one is 9. So they don't share their heights in common, but they do share their lengths and their widths. So all of their lengths, like I said, were 15, and all of their widths were 1 1/2, 1 1/2, 1 1/2. So you see how I did that right there. So for B, I said that they shared 15 times 1 1/2. And then when you do that, when you multiply those together, you should get 22 1/2 inches squared. And then for this part right here, it says, what does it represent? Those 2 right here, this length and this width, it represents the area of the base of the rectangular prism. So that's what these 2 numbers and the expression represent, is the area of the base of the rectangular prism. So that's B. Now for C, it's asking us to rewrite the numerical expression to show what they have in common. So what I did was, I knew that if I was to take my 15 1/2 and multiply them together, you would get your 22 1/2. So if you were to take that right there, you'd get 22 1/2. Multiply these together, 22 1/2. These 2 together, 22 1/2. So I know that this is what they have in common. So I'm going to put my 22 1/2 times 3. I'm taking what they don't have in common and I'm multiplying what it does have in common by it. 22 1/2 times 6. Again, taking what it doesn't have in common, which is my 6, and I'm multiplying it by what it does have in common. And then for the last one, I have my 22 1/2 times 9. It does not have any 9s in common, but it does have 22 1/2 in common. So that's what I did for that. And then it says, obviously, what they have in common is, I've said this a million times already, but I underlined it just to kind of reiterate it for myself and for you. 22.5 is what they have in common. That's why I underlined it all. So for D, it says, let's see here. Sorry, my paper is flying. It says, if we know volume for a rectangular prism as length times width, I just underlined that because that was important information for me, times height, what is another formula for volume that we could use based on these examples? So based on these examples that we see, what is another formula that we could use for volume? And for this one, you can use V equals base times height, which means volume equals base times height. And then in parentheses right here, I have volume equals the area of the base times the height. So there's that. And then it says, what is the area of the base for all the rectangular prisms? So when we're finding the area of the base, you want to multiply your length times your width. And we know that all of our lengths were 15 and all of our widths were 1 1/2. So when I take those two numbers, I already did the work right here, so I didn't do it down here. But when you take those two numbers, the length and the width, you multiply them together, 15 times 1 1/2, you get 22 1/2 inches squared. So that is your answer for down here. It says, what is the area of the base of all of the rectangular prisms? That's what it is. 22.5 is the area for the base. And again, you find that by multiplying the length and the width together of all of these. So that was page 151. Now, if we move on to page 152, it's asking us to determine the volume of each rectangular prism using either method. So what I did is I looked back over here, and you see how I labeled these like 1, 2, and 3. I used those same labels for this, 1, 2, and 3, to organize my work, organize my thoughts. So it asks us to determine the volume of each rectangular prism using either method. So what I did is I took my 22.5 and I multiplied it by the height for every single one for F, because I knew that the length times the width on all of these is going to be 22.5. So I went ahead and I said that V equals 22.5, which again, I found that by multiplying my length and my width, and 22.5 is the answer for all three of the shapes that you have. 22.5 times 3, which is my height. And when you multiply those two numbers together, you get 67.5 inches cubed. I did the same thing for 2, so I knew that my length and my width was going to be 22.5. I multiplied it by 6, and I got 135 inches cubed for that one. And then for number 3, I did the same thing. I used my formula. I said V equals 22.5 times 9, which is the height of my third shape right here. I'm getting these numbers from this shape right here. 9, right here, the height. And I multiplied them together, and I got 202.5 inches cubed for my answer for that one. So that's how I did F. Now for G, it's asking us to compare. So it says, how do the volumes of the first and second rectangular prisms compare? And then what about the volume of the first and third? So we're comparing the volume of the first and second rectangular prism. So I know that the volume of the first rectangular prism was 67.5 inches cubed, and the volume of the second was 135 inches cubed. So the volume of the second was twice the first. So that was your answer for that one. Volume of the second was twice the first. The volume of this is twice that. Now for the second part of the question, it asks the volumes of, it's asking us to find the volumes and compare the volumes of the first and the third. So I said that the volume of the third, which was 202.5 inches cubed, is triple the first, which is 67.5 inches cubed. So that is what I wrote for that right there. And when I printed this off, you had to do example 2, but when I printed it off, it cut it off, so I just kind of wrote it out on here. But for example 2, it gave you two numbers, and the two numbers were 3 1/4 and 2 1/2, and it asked you to find the volume using those two numbers. So what I did was I used my formula. I used V equals base times height, and it said in the problem what it was. So I have my V equals 3 1/4 times 2 1/2. And we've been doing this, but if you need a little refresher, we have our mixed numbers right here. And I want to make these mixed numbers into improper fractions so that way multiplying it is nice and easy for me. So what I did was I took my denominator and my whole number and I multiplied them. So 4 times 3 is 12. And then you do 12 plus 1 in your numerator is 13. So I got 13/4 right here. And then for 2 1/2, I did 2 times 2, which is 4. And then 4 plus 1, which is my numerator, is 5. And you're always going to keep the same denominator. So see how this denominator was 4, this one is 4. This one was 2, this one is 2. So you're always going to keep your same denominator. It's always going to stick with you. So what I love about multiplying fractions is that you don't need to find a common denominator. You can just go ahead, multiply your numerators across, multiply your denominators across. You don't need to find a common denominator, which makes the work a lot easier. So what I did was I took my two numerators. So I have 13 times 5, which gave me 65. And then I took my 4 times 2, which gave me 8. And then I have 65/8. But if I wanted to make this into a fraction, what I would do is I would do long division. So here's how I got this. Your answer is going to be 8 1/8 inches cubed. But here's how I got this if you're confused. I just did long division. So I did 65 divided by 8. I know that 8 can't go into 6, so I put an X over that place value. I know that 8 can go into 65 8 times. 8 times 8 is 64. I subtracted those two numbers. I got my remainder of 1. So I went ahead and I put my remainder up here. And this 8 right here, this little guy, he's acting as our denominator. So I have 8 1/8 inches cubed. And that's how I got that 8 1/8. I just did standard division for it. So that was your lesson. Module 5, Lesson 12 for Wednesday, April 1st, depending on when you're watching this. I am hosting a Google Meet session on Thursday, April 2nd from 2:30 to 3. So if you are confused with anything, I understand this whole distance learning thing is a lot different than learning in the classroom. It's a lot different to teach over a webcam and a phone and everything like that. So I understand things can get difficult. So if you don't understand something, please, 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 please speak up. Come on to Google Meet. Come on with questions. I will be hosting it. You can find the link to it on your Google Classroom dashboard. Miss Drexler, she posted the link for it on Tuesday. We're just going to use that same exact link. So I will be on there right at 2:30, ready to answer questions and say hello to everybody. I'm very excited to see everybody. Keep up the good work. You're all doing great, and I will see you all soon.